the triangles are the exact same thing and are in a different orientation, we can still consider them to be congruent triangles. And this is really important. Okay? So just remember that even though things are upside down, they still could be and realistically are congruent. So, when we talk about congruent triangles, this can be any shape, but obviously we're specifically talking about triangles at this time, so we're going to talk mostly about triangles. But again, this could be any shape that we wanted. But as I believe it was Bo said, this has to mean that we have the exact same size and shape. So I can never have an obtuse triangle be congruent to like a right triangle, for instance, right? Because it's definitely not the same shape, even though that they're both triangles. Right? So again, to show congruence, we're going to use our symbol of what? What's the congruent symbol? My equal sign with a little squiggly over top again. Okay? And then why things are congruent, or if we're talking about congruent triangles, we want to look at corresponding parts. Now we've heard this word before when we were talking about parallel lines and such. But what would be corresponding parts in two triangles? What's that mean?
Like
the angles, right? Or what else? What else would we talk about in a triangle besides the angles? The sides, okay? So when we're talking about the corresponding parts, what's this mean though, specifically? The angles that what? Are in the same spot. The sides that are in the same spot. That's the most important part. So the corresponding parts, there's going to be 6 corresponding parts. We're going to have 3 angles and 3 sides in the same spot. When you do this now, you have to make sure, when we're talking about corresponding parts or congruent triangles, that the vertices are written in the correct order. So for instance, if we went back to the triangles that we showed up on the board just a second ago, it's really important to understand that you go and write the vertices in the exact order that you're comparing the corresponding parts to. So in this particular case, now we've said all along that you should try to write it in alphabetical order. So on my left-hand triangle here, I should write as ABC. But realistically, it doesn't really matter where you start. So if Ryan looks at it and says, well, I'm going to start at the top all the time, and I'm going to do BAC, that's totally fine. So basically, you're writing your triangle however you see it. And again, maybe you want to do it from the same spot every time. Maybe you really want to do it in alphabetical order every time. So if I do alphabetical order, I'm going to say triangle ABC is congruent to triangle, and then I have to make sure that I go in the same order. So in this case, these 2 triangles, it's kind of hard to actually see besides maybe A and J, right? Being that quote-unquote right angle that it looks like, even though I didn't put the box in there, that they would be congruent. But if I would flip my other triangle around, the one on the right, then I would assume that angle B and angle K are in the same spot, and that they're the same thing. So when I do this, I want to make sure, if I write A first, in my second triangle on the right, I would want to start where? With K, right? Because it's at the top of my right-hand triangle. And then the quote-unquote, sorry, not K, J, right? Because J would actually be the quote-unquote right angle, even though we didn't put the box in there. And then is K in the same spot as B? And then C would have to go with L. So, right here, this is really important. This, I guess if you want to call it a sentence, is called a congruence statement. So this would be a way of showing what I want you to do or want you to write down, for instance. If I gave you this, it's just another way of making triangles on your paper. So instead of giving you actual triangles, I can give you this statement, and the statement tells you everything you need to know. So if I go by corresponding spots, what letters are congruent to each other, I'm looking at the letters that are in the same spot. So realistically, angle A is congruent to angle what? J, and then so on and so forth. Now, we could either use the triangles, but sometimes they might not give us those triangles, or we use the congruent statement. So then we would have two other sets of angles, which we've kind of already talked about, but it also shows us the sides that are congruent to each other. So what sides are congruent to each other in consideration with the letters in the right order? You know what I'm saying there? So, if I told you I'm looking at side AB, what side on the other one is congruent to AB? Either look at the statement here, or you can go back and look at the triangles. So if AB are the first two letters, I'm going to use the first two letters over here, so I would say JK. And then what's another group of sides? Any group. BC is congruent to KL. Perfect. So Ryan just looks at the last two letters and the last two letters. And so what's my third set? AC and JL. Perfect. So in your homework, they're going to say, list the corresponding parts. Whatever kind of shape you have, you should have that many groups of sides and groups of angles. So again, this only works if it's a congruent, whatever. I think the first example when we should start looking at examples is like a pentagon. So you can do this with any shape that you want, but you would go through. Now, realistically, if it's a pentagon or an octagon or even a triangle, how would they show me that I truly have congruent segments up there? What would they have to do? Or congruent angles? The slashes, right? So, I'm just going to make my own up here. And we said this was A, B, C. And then we turned this one around. And we said this was what, J? K was up here, and L was down here. So, realistically, when we do this, if I put a box, I should have a box over here. And then we're saying that B and K are the same thing. So now I can use an arc, or maybe I use two arcs because maybe we don't want to confuse the arc with the box. But if I have two arcs here, then I'm going to have two arcs over there. And then the last one I would put either just one, or I could have three arcs, and I have three arcs over there. And then, so the arcs show the angles that are congruent to each other. Somebody said we would use the slashes to do the same thing. But remember the other day when we talked about the sides and the angles going together? Or being kind of grouped together? So if angle B is congruent to angle K, the side opposite of angle B, which would be the side diagonal, would be this side down, what I would call the base of this triangle. I'm going to put slashes on this side, but because I've already talked about angle B having two arcs, I'm going to put two slashes in that side. And if I put two slashes here, then I'm going to put two slashes here. And then so on and so forth. So L, across from that, should have three slashes, and L goes with C, so that should have three slashes. And then, realistically, my box is just counting as 1. So, in order for me to prove or show that these are congruent, I need to have all of those things come about. Okay? And we're going to learn ways to show this in the next 3 or 4 days after we take our quiz. That's where the proofs come in, and that's where we look at other ways of showing congruence. Make sense? Okay. So, realistically, I can always give you another triangle and say triangle that x, y, z is congruent to triangle M, N, O. So, somebody tell me one group of angles that is congruent in those 2 triangles right there. What would we say? What? X. Okay, so X, Y, and MN would be the sides, right? One group of sides. That's right. X and M. Angle X is congruent to angle M. Another angle. Y and N. Another side. NO and YZ. Okay? So, again then, from this statement right here, I could actually draw triangles and show that same thing. I don't know really what size of the triangles they are, but I know that those 2 triangles are congruent. That makes sense? Okay? Which leads us to the most important part of the day. Okay? This is a fun one to say. So we're going to talk about the definition of congruent triangles. We will use this as a reason why in our proofs as much as anything in the next week or 2. Okay? A lot of times the definition of congruent triangles has an acronym, which is CPCTC. Okay? Which means, are we ready? Corresponding parts, you might see in my P, of, it's a little of, because that word doesn't matter. Well, it matters, but congruent triangles. Now another little word, are congruent. So instead of trying to write out corresponding parts of congruent triangles are congruent, they shorten it up and say it's CPCTC. Now, a lot of you aren't going to remember that it's CPCTC, so you'll put a bunch of C's and a couple P's and throw it down on the paper and say, well, that's what I meant. All right. So, any idea what this means? The corresponding parts of congruent triangles are congruent. Well,
if the angle is corresponding to the other triangle,
basically, right? In a sense, it's like this right here. What this is saying is, if I have enough information to show that these 2 triangles are congruent, the rest of the pieces have to be congruent. So, in the next few days, we're going to learn different ways to show congruency. Angle, side, side, side angle, side. If I have a combination of those 3 things, then this triangle is congruent to that triangle, and I don't even have to have all of those arcs and all of those slashes on my triangle. If I have 3 of the things that I just said in some special combinations, then we can say the rest of the parts have to be congruent because of this definition right here. That make sense? Obviously, it will make more sense when we actually introduce the ways of showing congruency, but you will use this a lot. So this is something where they'll say, prove that this side right here is congruent to this side. Well, first I need to prove that my triangles are congruent, and then if my triangles are congruent, then I can say this part because all the rest of the pieces have to be congruent. Okay? CP, CT, C. Remember that, yes. All right? Really important thing. Next one. Here in 4.3. So this would be kind of the first way that we're going to prove that triangles are congruent. This is called the third angle theorem. Hopefully this is pretty self-explanatory when we start writing it down. I'm too low already. So what this says is, if two angles in one triangle, again, a lot of abbreviations, so if you got any questions, just let me know, are congruent to two angles in a second triangle, then obviously what? Then the third angles are congruent. Hopefully this makes sense to you. But what this is saying is this. So those of you that don't like words, you like pictures. If I put a box in there, and then I put that this angle right here is 30 degrees, and this angle right here is 30 degrees. Is there any way possible that this angle right here cannot be congruent to this angle right here if those two things are congruent? That's what that theorem says. If I have two angles in one triangle that are congruent to two angles in the other triangle, the other angles have to be congruent. And hopefully that's pretty self-explanatory. But they're going to try to trick you. So be really careful in your assignment today. And then the last thing that they talk about again is theorem 4.4, which is those words that we've talked about a lot. So the congruence of triangles is reflexive. What were the other words? Do you remember? Symmetric. And what else? Symmetric. I forgot one. Transitive. Perfect. So what does it mean again? If things are reflexive, they're what? If things are reflexive, basically that means I'm taking a triangle and comparing it exactly to itself. A lot of the times, reflexive in triangles will be like this. If I have a triangle right here and then they draw another line across this, does everybody realize that there's two triangles right there? And basically, this angle right there is in both of those triangles. So if we called this top triangle A, B, C, and then put D and E right here, angle A would be congruent to itself by the reflexive property because it's the exact same angle. That's what that's saying, okay? Symmetric, comparing two triangles to each other both ways, meaning that you're just putting the letters in different order, basically, but you're still talking about two triangles. And then the transitive property, that would actually probably include three triangles. So if angle 1 is congruent to angle 2, and then angle 2 is congruent to angle 3 in the third one, obviously angle 1 has to be congruent to angle 3. So you're talking about three different things, but you still use the transitive. And we've used the transitive quite a bit. Now realize that I could do all three of these things, not only with the angles, but with the sides too. So it works for segments and it works for angles. Make sense? All right. Any questions with the words? And let's look at some examples. What are you dropping your pencil for? So again, I think the first example, like I said, they start out with not a non-triangle, but the concept is exactly the same thing. What's my shape here? It is a pentagon, right? So again, it does not matter how you list the vertices. Again, if I want to go in alphabetical order, I would start at A and go around this way, right? So it does not matter. Somebody say how you would name this pentagon right here. I would name it as what? Pentagon what? A, B, C, D, E, right? So then it is congruent to what? If you start at A and go in alphabetical order, I have to start with what in my second pentagon? R, and I would say what? T, P, S, Q. That make sense? So the corresponding parts then are those angles in those orders and the sides. And then realistically, you could come back and you could show that in a congruent statement, or you could come up here and you could put all the little slashes and everything. So if they don't give you a congruent statement like this, they have to put the little arcs and the little slashes on your figures. That make sense? Okay. So then we get into something like this. So we're going to use this to find certain things. So in the diagram, it tells you that triangle ITP is congruent to triangle NGO. You cannot argue the given. That would be, in a sense, the given. I can never argue the given. So again, that's where I would start out with my proofs with that statement right there. But that is a for sure. So if you wanted to, again now, they're giving us some angles over here, but they're giving us some sides over here. So if it helps, by all means, not in your book, because I've seen a lot of writing in the book when I've come around to help you, is that IT has to be congruent to NG. I would come through and I'd put little slashes there. And then I know that I has to be, this one right here would be my 1. Would have to be, bless you, 1 to that. Okay? And then, again, the only reason I use 1 and 1 is because if I'm going to put 1 slash, I want the angle to have the same number of arcs. Just so I know that they're basically corresponding and go together. Okay? Now, again, this is where the book, I think, sometimes messes up because they don't always do that. All right? So, how the heck do I find X and Y? What do I need to compare my X? Well, notice here in this right here, it has both an X and a Y. Can I realistically start with that? No, because it has 2 variables. So I got to go and find my 1 variable, which is down here. So what am I going to take 6y minus 14 and set it equal to? 40, because it's in the same spot, right? So then once I find that y, then I can stick it back into this part that I circled and find my x, but I'm going to set this part equal to what? 7.5, right? You need to see the math. Anybody? We got plenty of time, so don't be ashamed if you want to see it. Just because so this is one where they start to try to kind of get you confused. In the diagram, triangle FHJ is congruent to triangle HFG. Does everybody understand that FH is in both triangles? This part right here, this side, I'm sharing in both cases, so it's in both triangles. That's where we would use reflexive, if we had to in our proof, and we will do that, okay? So they'll ask you to prove that these triangles are congruent. I can always say FH is congruent to FH by reflexive. Because they're the same thing. They're touching. But they have to be in both triangles. So, here's the next question. Is this line right here parallel to this line right here? Do I know that for certain? No. Okay? Now, in all honesty, this looks like a parallelogram. So, if they would tell you that this is a parallelogram, then we could know that this is congruent to this. Or, sorry, parallel to it. Because of the definition of parallelogram, we'll have a whole section about quadrilaterals and parallelograms. Okay? So what I'm getting at is I have no idea that this angle right here and this angle right here are congruent by alternate interior angles. But if they tell me this, angle F and angle H are still congruent because they told me that. That makes sense? So again, I would take 6x plus 8 and set it equal to 35. And then I would take 2y minus 3 and set it equal to 2.5. Again, you need to see the math. All right. So now we look at weird things. A drawing of a tower's roof is composed of congruent triangles, all converging at a point at the top. If angle IJK is congruent to angle IKJ, that's one that's kind of really confusing because all the letters are the same, but they're not in the same order. Okay, so I'm comparing the I's and the K and J and then the K and the J, but they're in different spots, right? So it's kind of a weird one. And the measure of angle IJK is 72. Can I find the measure of angle JIH? What do you think? The biggest thing for this is what? When they say this right here, composed of congruent triangles all converging at the point. So this triangle right here is congruent to what? This triangle on the side, this triangle on the side, the triangle on the back. Even though that we can't see that, because they tell me that in the paragraph, I have to believe that. Okay, so if IJK is congruent to IKJ, what does that mean about this triangle right here? Because of this statement right here. It's isosceles triangle, right? If two of the angles are congruent, or two of the sides are congruent in a triangle, it has to be an isosceles triangle. So if they are congruent and IJK is 72, can I find JIH? So even though that we're talking about two different triangles, we're really talking about the same angle, right? Because they tell us that all the triangles are congruent. So IJK is 72. IJK is 72. That means this has to be 72. So if both of these are 72, can I find this top angle? By doing what? Exactly right. Everybody hear what Con said? So I'm going to take 72 plus 72 and subtract it from 180. And again, even though that they switched it and asked us to actually find this angle up here, it's still the same as this angle that Con just found because they're all congruent. Make sense? Again, do not be afraid to redraw this on your paper. It does not have to be a perfect drawing. You just need this so you can draw some of those things and write some of those things in there. Put little slashes, put little arcs in there. Don't do it on your book. Same thing happens here, right? A drawing of a tile contains a series of triangles, rectangles, squares, and a circle. Okay, so automatically, if they tell me it's a square, what's true about it? All the sides are the equal, right? So we're assuming that this is a square and the outside part is a square. Okay? So, triangle KLM, can you see where that is? That's this little triangle right here. Is congruent to NJL, which is up here. KLM is congruent to KML, or angles. So if they tell me that KLM and KML, I said it in opposite order, are congruent. What's true about this triangle right here again? It's an isosceles triangle. Okay? So, here's the other thing. Can I assume that this triangle right here and this triangle right here are the same? Yes, because they told me that. But can I assume that this one is also? Yes, I would assume so. Okay? But I don't even know if they go that far. So if KML is 47 degrees, KML, find LNJ. LNJ. So again, basically, I'm taking this triangle and putting it on top of this one. So LNJ is in the same spot as MKL. And so can I find my answer? Basically exactly what Con said in the last one, right? If this is 47.5, so is this. And then I would add those two up, subtract it from my 180 to get this one. Make sense? You guys need to have this class at a different period so you can actually think. And then we'd have a proof. But I think today the proof is just one of these kind. So you just have to fill things in. But notice, if I want something at the end, I'm going to put CPCTC because all the parts have to be congruent. So just remember that for your proof. Okay? Remember, good proof, start out with a given. Write all the logical steps, but be specific. And even say the most obvious things. And then end with your proof statement. The first, I can start out with the given because it is given, but the proof I have to come up with the reason why. Today, the reason why for your proof will probably be that CPCTC. So there's your point, or there's your problems. Let's see if they're actually true. So I make you try to do one proof. Number 23.